has many uses? Heck yeah it does. The basic principles, they are legit. Let's see them out, and let's learn how. This is CALCULUS, yeah. Let's work first with limits. They're really rather simple. We can even analyze using L'Hopital's rule. I've got many tricks to solve these limits, so these big complex things to turn to basic math. 0 and infinity, multiplied, divided, and added no longer is puzzling or too complicated. We have, these techniques: exponentiation, manipulation. Now how cool is that?
Differentiate, integrate, and sum up all the elements in an infinite series. Work with Cartesian, polar, and parametric curves. My skills were never so divine.
Man, I'm pumping, working under the fluid force. Checking out these springs like, yeah, they're strong, but they don't have the force of this bucket and rope. Gotta hit the books and get some practice with your method, so it's easy to use and ditch when I need them. Check the axis of revolution, X or Y or any line. Consider that the integrand is about really time, yo. I know what it's like between these two curves. There's another application of these integrals, just like the ones of revolutionals. Knew they'd be a lot, but never ones like this. Euler, using slope and values. Yeah, we can use them to approximate the Y just using the slope and our X step, oh my. But I really wanted more applications, so I expanded my horizons and began to work with curve lengths. It was really easy, yeah, all you need is derivative. Set up the integral, calculate it, then you got it.
Differentiate, integrate, and sum up all the elements in an infinite series. Work with Cartesian, polar, and parametric curves. My skills were never so divine.
Cosine and sine, and 1 over 1 minus x knowing time. These Maclaurin series are necessary to have in mind so that we can write ones that closely align, converge, diverge with the intervals on. Then in turn we'll see what will happen if we find a limit of sub n approaches infinity. Anything not 0 is out of this vicinity. Got the ratio test, and it's easy too. Power and geo, keeping it real. All of my tests sitting in my toolbox. D or L, comparison for all. Do you recall all the neat tricks that we learned in the fall? Integrating expressions with respect to y'all. You can count coins, but we're not gonna stall. Parametrics got an x and y, so when we differentiate we got dx, dy. That's just how we parametrize, because we got polar curves in terms of r and theta. Find an area with a half and squaring the curves. You gotta know position, velocity, acceleration to a t, and vector notation, show relation, and now we about finished. You
differentiate, integrate, and sum up all the elements in an infinite series. Work with Cartesian, polar, and parametric curves. My skills were never so divine. Differentiate, integrate, and sum up all the elements in an infinite series. Work with Cartesian,